afternoon, good evening, good morning. Welcome all. It's a pleasure to have you here. We are very excited and very proud to present you our new baby. So it will be a two voices presentation. We'll start with some historical data. My name is Arnaud Dubat. I am business developer for KPM and mostly in charge of CHOPIN. And I will be sharing the floor with Lena Bosc-Bierne, who is our application manager. So together we try to explain you what's in our new baby, what's in this new Mixolab 300, which we see as a tool really bringing something new and above all useful to the industry. So let's start with a little bit of historical data. We have this one here, and here we go. So the story started in 1970. Lena was not there, and I was not there either. But at this time, scientists, engineer in the northern part of France, in the border of Belgium, invented a machine called the Petrinex. So don't go and search on the internet. I did that, and you will find nothing about the Petrinex. It disappeared quite rapidly because it was a machine made by one man in his garage, and when the guy retired, of course he stopped manufacturing the machine. But yet, when I started working for the company, a little bit later than that, but still the people in the northern part of France and in Belgium, they were asking me about this Petrinex because it was very nice for analyzing wheats and classifying wheat. So I heard a lot about this machine. I had a chance to see one time. And then I was very surprised in the 19th when I saw this new tool, which was called the multigraph. And it was the same. It came from Belgium. And basically what the two engineers working on this machine did, they took the Petrinex concept and they make it a little bit more modern with software, with a little bit more of control, etc. And when we saw that, we find it very interesting in Chopin. We find it very interesting because not only it was giving information that we are used to, such as water absorption, dose stability, mixing time, things that we can have by other ways, but it was bringing something more. It was bringing us the capacity of understanding what is happening to the dough when we are heating up the dough and when we are cooling down the dough. These are kind of information we can have on other tools like amylograph or RVA, but the uniqueness of the multigraph at this time it is that it is doing that on the dough system, not on the batter. So it was not about copying something existing, it was really bringing something more to the industry. So making a long story short, we have been partnership with this company, and we came in 2005 to bring to the market the first Mixolab. So that's fully developed by Chopin based on the concept we have been mentioning above. And basically what this machine is doing is mixing a dough and recording the torque, but adding to the traditional way of doing it, this heating up and cooling down phases. So very rapidly, it was a machine that was patented. And quite rapidly, when we know the time it takes to make a standard, it became an international standard. So today it is ISO, ICC, AACC, and many others. So it is standardized in all the world. In its application for testing flour. Okay, so it's a machine today which is on the market for many years. It's well recognized. It's used more and more every day, and it is based on very sound science. In 2016, we introduced the Mixolab 2. The Mixolab 2 was an improvement of Mixolab 1. Based on the observation we had with our users, the first users, and they say, okay, maybe this little thing could be improved and this little thing could be improved. The main improvement was about the software, because here in this software, for instance, we have been implementing the capacity to measure seriously something which is similar to the farinograph, because that was a request from the market. So that makes that as of today, we have more than 900 Mixolab operating every day in the world. It is growing every day, and we are very happy about that. It's a long story, as you can see, and that's how it works in our markets. But we are very proud to have been one of the company really bringing something new to the industry. And if it's successful, it's not only because it's new, because it's not new anymore, the Mixolab from 2005. It's really because it's bringing something different and something useful. So what were the key of success for the Mixolab? The first one is that, as I explained a little bit above, and if you want more information about that, we can give you a lot of details, and we can organize whatever kind of meeting if you need to have more details in some parts. But basically, you imagine a little dough mixer that we are going to see here. So that's the dough mixer. And we are recording the resistance of the dough during mixing. So at the first stage, we are going to measure the absorption. We are going to adjust the consistency, and we are going to know the water absorption, exactly like what we are doing in a farinograph. We are looking at the stability of the dough, but here you see, we can see a drop because we are heating up the dough. So we have a drop, and that's indicating how the protein is behaving. And that's where it becomes really, really interesting and important. Here we can see a change in the curve. What we are observing here is the starch phase in the dough. We need to remember something very, very, very important. Every time you are buying 1 ton of flour, every time you are selling 1 ton of flour, you are buying or selling 700 kilos of starch. And starch is extremely functional. Starch will influence your color, it will influence the volume, it will influence the structure, the crispiness, many things, including the shelf life of the product. But the fact is that in our laboratories, we are focusing a lot on the protein, which is good, but maybe it's not enough. And what we observe many times is you can have flour within specification, classical specification, which are not performing well on the process. The question is why? Well, maybe one part of the answer is because we are not having a full understanding of what is the flour properties. And if you do not look at the starch property, obviously you're missing 72%, 70% of the flour. So that's a very important thing. So it is a tool that can be used for R&D. Most of the ingredient enzymes company, they are today using the Mixolab. It's used extensively by the millers, and more it is used by the bakers. And that's why it has been opening new ideas that Lena is going to present you later. But it's a very versatile tool. You can use standardized protocol, but it's totally open. You can really create your protocol. And of course, we have a full team of people, like in Lena's team, which are here to support you should you want to do this kind of thing. So let's spend a little moment on the farinograph, because when we came with this machine, our aim was not to copy existing tools, but customers asked us, say, okay, you are mixing the dough, I would like to have equivalent, or I would like to have a kind of farinograph curves. So we have been inventing a special system, because the mixing system is very, very different. So you do not have the same curve. It's not the same signal, but we have been doing our homework, and we are able, thanks to this protocol, to have the same result as a farinograph. And it is proven not only by us, of course, we did a homework here again, and we have been checking before putting that on the market that it was working. But as you saw, it's on the market since 2016. And today, one good example we have that I will not detail, but you have the main information here. If you look at the water absorption compared to the farinograph, it's very good. It's very good also for the weakening. It's very good for the stability, and it's very good also for the development time. So we have many customers today using the Mixolab to communicate with other people using the phorinograph. And we included have the BPA, that's a proficiency testing scheme, and they accept you to participate to the same circuit even if you are using a Mixolab or a phorinograph, which is one kind of evidence that if this kind of program allows these two tools to work together, it means that the results are not significantly different or not systematically different, of course. So same thing. And I will just finish on that because, yeah, we can do the phorinograph. But the idea of the Mixolab was to do more, to propose you something else. I told you before, just looking at the protein, sorry, is not enough because starch phase is so important. So the bakery challenges has been evolving a lot and particularly evolving since the COVID very, very rapidly. But if we look on the long term, this is what industrial bakery was looking like in the 1920s. That means 100 years ago. Why 100 years ago? It is because 100 years ago, that's where the phorinograph, the alveograph, and most of the tools we are using today were invented. So these tools were invented where the world was like that. You can do the parallel with the milling industry. Today, if you go there, it's not even today, it's 2000, but today, if you go to a baking plant, it's a huge plant. We are producing thousands of loaves of bread or biscuits per hour. It's really huge. And in this plant, you see very little people. So it's all about the process. And when it's all about the process like this, if you look at the dough, and if you look at the dough being squeezed, being rounded, being whatever, laminated, you understand how it is important to master the quality of your dough. And the way we are qualifying or we are mastering the quality of the dough is by trying to master the flour. One thing which is very important also in the bakery is that here they are all master bakers. The fact of having master bakers in the industry makes it possible that if the flour characteristics are not perfect, these guys, they know how to twist the process. They will put a little bit more water, mix a little bit longer, whatever. They know how to fix it. The thing is, and this is worldwide, in all the companies we have been visiting, everybody's telling us the same story. These people are disappearing. Why? Because they are just retiring. And the thing is that the new people entering into the companies, they do not stay long enough to get to the point where they have this expertise. Reaching this level of expertise takes time. So that's a real challenge for the industry because they have expertise here and the expertise is leaving the company. So the idea is, how could I put number? How can I know this feeling of the guy, put numbers so everybody is able to do the same thing? So that's something we have been hearing and really something that was one of the main driver to develop what Lena is going to present you right now. So a lot of challenges, that's just one of them, but a lot of challenges, and the baking industry is really changing and becoming much more demanding, let's say, in terms of quality. So the idea is really to put objective data on the feeling. The other thing I have been really witnessing is a big change, even for me, because when I was at the milling school, I was taught like that. Oh, you want to make a pan bread, and we still find that from ChatGPT. You want to make a pan bread, you need to have 11, 13% protein, a W from the alveo between 180, 280, this type of thing. If there is only one thing I learned during my career in this industry is that this kind of advice do not work. I cannot tell anyone this is the type of flour you need. This type of predicting things does not work. But you can find them everywhere. And that's what we call the flour guru concept. You know, you have people telling Other people, you are making pizza. I'm going to tell you that if you are making a pizza, you need to have a W value of 250. You don't know where it comes from. It comes from the literature. You don't know. One thing is sure. If you don't know the process, if you don't know the formula, if you don't know how the flour is going to be used, you are absolutely unable to determine what is a good flour. Good flour is a concept that does not exist. There is no good or bad flour. There is well-adapted flour or non-well adapted flour. And what we are doing now, we are doing it backwards. We help the bakers because they are the one who know if the flour is working or not. Because if it's not working, they suffer the pain. So they are able to say, okay, this flour was perfect for me, this flour was not perfect for me. So we can take sample of the well-performing one, sample of the bad-performing one, analyze them, and be able to say, okay, the good one looks like that. And sometimes it's not about the protein content. It's not about the W. Many times it's about the starch properties that we are not measuring. So you can have specification and still receive flour which is not working well. We made a survey a couple of years ago. 96% of the people told us, yes, we do have problem with our flour, and the flour, they are within specification. And that's the gap between quality control of the flour and the people in the process. So there is a gap that can be filled here, and that's really what we are going to propose you today. Why? Because when you go to a bakery, you understand that between the flour and the final product, there is the plant. And when you visit the plant, you can understand all the variables you have about the formulas. Everybody is not using the same formula, the same enzyme, the same ingredient. The process is never the same. Sometimes even in two lines in the same plant, it's not the same process. So it can go well on line A and not well on line B. Today, the master bakers, they know how to adjust each line. But tomorrow, we also need to look at the machine. We need to look at the temperature because the same product made in, let's say, Poland or in Senegal, it's not the same story. You don't have the same conditions. So it's impacting how the dough is going to perform. And so it's impacting the kind of flour you need to start with. All of that. So it means that flour is a basis. We know we cannot predict if it will be good or not, but what we can do at KPM with our tools, we can really help you put numbers and know exactly what is good for you, not for the customer, not for the neighbor, for you. We can help you identify that, and then you can discuss with the miller, which is good for the miller also, because today the miller, they are making a lot of tests and they are sending the flour and it's not working, and nobody understands why. Maybe it's because we're always using the same tools as 100 years ago. Maybe it's time for a little bit innovation. So dough is definitely the missing link. You know, we are starting from the flour and we want to predict the bread, or we want to make this direct link between flour and bread. But in between, there is the dough. And the dough is impacted by the process. So if we can measure the dough, then we are making a shorter way. We can go from the flour to the dough, from the dough to the final product, and we better understand how each one is impacting. More information, more measure, more control. And based on that, we have been using two things we have been developing over the time. You know, in Chopin, we are sometimes developing things that we do not put on the market because it's not ready or many reasons. And that's one thing we did in 2007, 8, we are not really sure. But you see, we have been working on a little tool that we can sample a dough from the production or from the bakery, whatever, already formed dough, and we can drop it into the system and we can measure the quality of this dough. Very easy. And in parallel, we have been working for other application, basically for gluten-free application. We have a lot of application on gluten-free, and you know, gluten-free is sometimes using very liquid formulas like batters. On the standard Mixolab, because of the design, we can have some leaks on the mixer. So we have been developing a tight mixer, so we can use that for more liquid dough. And we got some little successes on that. But so far, these tools, They were for the dough kit. It was more adapted to dry dough. We cannot use it for batters, and we know there is a real need for people using batters. We did not have proper software, so it means we can do it, but you need to twist a little bit the existing system. So it's not like plug and play, not extremely user friendly. We can do it, but not easy. On the other side, well, we had the tight mixer, but we needed to work a little bit on the robustness, on different type of condition, etc., etc. But here is a little work that was done in Spain that has been using this tight mixer, and we can say how promising it is. So now is the time to show you how we have been integrating these two things to make a new tool adapted to the analysis of dough, flour and dough. And that's where I leave the floor to Lena.
Thank you, Arnaud. So let me share my screen.
Meanwhile, you are sharing your screen. I just forgot. If you have questions during the thing, please just use the little Q&A box to place your question, and we will answer all of them at the end of the presentation.
Thank you, Arnaud. You told that actually in the chat at the beginning. So
yeah, but maybe
some may not have said it. But so yes, if you have any question, please do not hesitate to share during the presentation. We will go over everything at the end. But thank you, Arnaud, very much for this introduction. I don't think it needs to go anywhere further before presenting our latest innovation, the Mixolab 300. So this is an instrument that was designed to analyze both flour and dough in order to get the maximum of information on how the flour is impacted by the other ingredients, how the dough is impacted by the other ingredients and flour, how the process impacts all of that, to make a better connection between flour and final products, and to better assess the process and other ingredients. So the question is, how do we do that? How do we analyze dough with a Mixolab? And in order to do that, we have developed 3 tools. The first one is an adapted mixing bowl. So as Arnaud mentioned, with liquid dough or liquid batters, with some products like that, we may experience some leakages with the standard mixing bowl. So we have developed a tight mixing bowl that is dedicated for dough analysis. So that means that the Mixolab 300 comes with 2 mixing bowls, one dedicated for flour test and one dedicated to dough tests. And then we have a specific introduction kit. So the introduction kit has been designed to be as easy as possible to use in order to put your dough, any kind of dough, into the Mixolab. But just being able to put the dough inside of an instrument is nothing if you cannot do anything with the results. And so the idea was also to provide with a companion to help you analyze the results, which is a new software called the Mixo Pro software, which comes with 2 modes. The first one is the same as you may already know if you are a Mixolab user. This is the flour mode. And another mode, which is dedicated purely to dough analysis. So I will come back in details in all of those functionalities. So first thing first, the mixing bowls. So as mentioned, we have now 2 types of mixing bowl. One that is the standard one used for flour test or any kind of powder test with water injection. And a new one for dough, any types of dough, even very liquid ones, because we have ensured the tightness of this mixing bowl. The tightness is ensured thanks to different systems, different seals. So we have here seals on the wall, on the flanges of the Mixolab to avoid leakages from the side. We also have specific lip seals here that we can see on the blades to avoid leakages from the blades. And to accommodate with these seals, we also have new bearing rings to limit friction and wearing. Just for information, this patent is in procedure, and there is a patent in procedure, sorry, for this mixing bowl. and we should have news from that very soon. So we are very happy with this system. And then we have a specific introduction kit. So here you have an overview. You can see the introduction kit is located here on the top of the cover. And it's basically a white chimney with 2 buttons. Those 2 buttons here are used to easily remove and put back the introduction kit easy in between tests or at the end of the day to make sure that we can clean it easily. And of course, this introduction kit comes with specific accessories, including a nozzle, a specific nozzle that was adapted to the length, to the height of the introduction kit and to the width of the introduction kit. And also, sorry, starting again. And also some accessories such as an adapted funnel for the flower and very interestingly, also a pushing tool. So I will come back to this pushing tool in just a minute. So in the end, the idea was really to make the dough introduction as simple as possible. So what you do is that you just launch the test, shape the dough a little bit, drop it into the mixer and place the pushing tool on top of it in order to make sure that you don't have any water evaporation during the test, because this is a test that is heating up the dough and we don't want to lose water during the test. So the pushing tool is useful for that, but not only. And it actually comes in very handy when we are working with less, let's say, traditional dough. This was a very easy one. But with this new system, we can also work with very liquid dough batters, such as a pancake dough, for instance, little bit more consistent, such as cake batters. And here we can see that if you have some on the walls of the introduction kit, we can use the pushing tool in order to make sure that all the product was actually introduced into the mixing bowl, is participating to the tests. We can also work with crumble dough. So here we have used the flour funnel in order to facilitate the introduction of the crumble dough. But if you're working with a hard dough, such as biscuits or crackers, or even pasta dough, something that you can shape, this is not a problem either. You can just shape it quickly, introduce it, and that's it. And we can go all the way up to the most challenging dough, such as this one, which has been made on purpose, very, very sticky. So of course, introduction is in any case a little bit more challenging, but thanks to the pushing tool, you can see that all the product was easily introduced into the system and is getting mixed quite easily as well. So really, there is no longer limitation in terms of what we can or cannot analyze. But most importantly are the results. And so here you can see some duplicate tests. So we have made repeatability tests for each of the presented formula. For bread dough, for the sticky dough, for the pancake dough, the crumble one, the cake dough. And here you have a comparison of all the curves. And what we can see is that we are extremely repeatable and we are extremely discriminant. So that really shows the value of the tests. So sometimes we have some unexpected or surprising phenomena that we are not really able to explain, just like with the crumble dough here. There is something happening at high temperature, which shows the importance of heating the dough. Again, there is a lot happening when we heat up the dough. So there is something here. I don't know exactly why, but I don't really need to understand why, as long as I see it. If I see it, I can act on it. I can improve it. I can know what is good. I cannot what is not good. So the entire point here is to provide the maximum amount of data. And here I have the solution to obtain that with dough. But it's not just about dough. As mentioned, the Mixolab 300 is an instrument that works with both flour and dough. There are a couple of advantages on the Mixolab 300 for flour test as well. The first is the improved funnel. Because of the introduction kit, we have worked on a wider funnel, meaning that the introduction is easier of the flour. And also, For flours that tends to be a little bit sticky or that have lumps, if you are Mixolab 2 or Mixolab 1 users, you must know this difficulty is that with this kind of flour, when you introduce it into the funnel, the traditional one, it cannot flow so well. And so sometimes you have to go like clack, 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 clack with the funnel, which is not ideal. Here with this new funnel, this is no longer a problem. So this is a small improvement, yes, that is for sure, but this is one of the improvements that really matters for the operator. Our lab technician, she's very skilled in Mixolab test altogether, and she's never going back to the Mixolab 2, or at least she doesn't want to. And then another option that maybe you know or you don't know, but there was always the possibility with the Mixolab to introduce external liquid, or very useful for additive manufacture, actually, that have to dissolve the additive into water, for instance. So there was always the option. But because of the shape of the nozzle, that is quite small with the Mixolab 2, the introduction of a large amount of liquid is quite challenging, and it can take a very long time. If you focus here on Mixolab 300 test, introducing 5 milliliter of water, it's like 2 seconds. When introducing 5 milliliter of water, here, thanks to Mixolab 2, takes longer. You can see the water dripping. This is not really efficient. And if you go too fast, then the water may come out, or the liquid may come out the other side. So definitely not ideal. Small improvements, but still very useful for people who need it. And then we needed something companion to help us with the data analysis. So we have worked on a dedicated software called the MixoPro software. The MixoPro software comes with 2 modes, as mentioned previously. A flour mode that comes with a broad range of protocols and functionalities, such as the CHOPIN Plus, that is our standard protocol that can be used with a blending load that is associated with a profiler for quality control, for which you can do additive analysis, and of course, simulator test to predict farinograph data, but also other kind of protocol, variable speed, hybrid, in order to really increase the possibilities and increase the testing options. So this is same as Mixolab 2 with an improved new and improved design, but this is the same functionalities as Mixolab 2. However, the real novelty is that we have worked on a specific mode for dough analysis that is composed of 2 main parts. The first part is about instant consistency tests. So this is a very quick test that is made to monitor the consistency of the dough on the line of production, to really replace, or not replace, but put data on the touch feeling of the master baker. And then the other option is the full test, with which we enjoy the full capacity of the Mixolab to heat up and cool down the dough, and we access a maximum of information, which is clearly the best option for R&D on your product development. So I will present those 2 options a little bit in greater detail. So about the instant consistency test, the idea is really that, as Arnaud said, many master bakers are retiring, and this is not so easy to train new people in having this sensitivity to know, oh, this is a good dough, this is not a good dough, to know, oh, I need to put 1 liter more water, to put less deactivated yeast, or to increase the proofing time. This is something that takes a very, very, very long time to be trained. And new people, they are not sticking around too long to get this expertise. And most of the time, of course, this is a generality. So the idea is really to have an objective data to know what is good and what is not good for a specific process. So how do we do that? Well, the first thing is that we have to learn. Every dough is unique. Your dough is unique. There is not another one in the world that is exactly the same with the same properties. So we need to learn, and we need to create a specific protocol for your dough. So this is why in the software you have a learning mode to help you design this specific protocol. Once it is done, that is very straightforward. you just need to analyze dough. And as you saw, it's quite simple to do, just throw the dough inside. And basically, if you analyze good dough, dough that are functioning all right during the process, no stickiness, no tearings, no difficulties in the process, and that give a good final product, well, you have the basis to design your own specification. So the consistency must be between this and that, and this, you know, this is a good dough. Once you have that, the system can be used by anyone, really. Even the newest operators with the least skills, they will be able to take a dough, place it into the Mixolab, and the results will be displayed according to your specification. So if it is displayed in green, perfect. Then the operator will know that everything is under control. And if it displayed in orange or red, then at least he knows that he must do something. It can be change something on the line, or if he doesn't know, go see someone who knows, the master baker or his boss or whomever. But at least everyone will have the ability to tell, oh, there is something going on, even without training. And because you have that, you have also the possibility in the software to draw control charts. And these control charts may help you to make links with the process. Like for instance, here, we can see that all of a sudden there was a drop in the consistency. Still remaining within the specification, but still there was a drop. When this drop happened, might help us determine if it was because of a new flour lot, or if it's because a new ingredient lot, or because a new operator shift, or because whatever. But it may help you make links with your process. And so in the end, this is just to show you a little bit the kind of results that we can obtain. Here, this first project was made with a company based in the UK making donuts. And what we did here is that we analyzed all the dough after mixing, and we classified them in red, according if they were not good, or in green, according if they were good. And here in this specific situation, a bad dough was associated to the final product having defaults, and particularly the hole was deformed or absent. And as you can see, it's very easy to discriminate the two populations and to design specifications for the good dough, objective specification. So in very short time, here in only 2 minutes, we can have a specification, and we can know that a good dough must be between 0.69 and 0.8 Newton meter. Another example that I really like, because it shows two things. So this is an example with which on crackers this time. So this was obtained on crackers. And what we can see here is that, first of all, the discrimination, or the best discrimination, is achieved after 6 minutes. So it shows the importance of the learning mode, the importance of having to learn from your dough to determine what is the best time for your protocol, for instance. And still, in this case, the discrimination is not perfect. But here, the big difference between those two, those two production is that here on the left, the donut production, the people on the line of production, they were able to feel the difference between a good dough and a bad dough. So this was just about putting number on this feeling. But here, for the cracker production, expert operators on the line of production, I mean, I saw them, they are able to see differences between things that for me are just completely the same. But even those experienced operators, they were not able to make the difference between good and bad. And the fact that a Mixolab, a real logical tool, can be more precise than a human hand, I mean, this is just amazing. In both scenarios, the protocol are quite short. They are always shorter than 8 minutes, which makes it completely compatible with production speeds. Even if you are making like one batch every 15 minutes, this is still manageable by the Mixolab and you can control your entire production. And of course, here I presented results obtained on mixers just after mixing. I mean, on dough taken just after mixer, but nothing prevents you to have a full control over your process and to identify key steps in the process and to follow up the consistency of those dough at those steps. So here, we are back to the donuts manufacturing, and we have analyzed the dough after mixing, after division, after proofing, and then after boiling. By doing that, you can set up specifications at all key steps of your process and to know exactly where a discrepancy is coming from. We have a customer in Chile who did that. They have a Mixolab with which they have designed specification for the flour. And then they have worked on the process, analyzing the dough after mixing, after this, after that, after every, let's say, key steps. And now in the daily life, in routine, when they analyze their flour and their dough, if everything is okay with the flour, that's not the flour. If everything is okay with the mixer, that's not the mixer. And then after proofing, let's say, oh, here I have a discrepancy. So I know exactly that it was between this point and this point that it happened. So I know where I need to look and where I need to act. And then there is another option, which is the full test option. And during this full test, what we do is that we are heating up the dough and cooling it down. And by doing that, we really access a maximum of information. We see the starch, but not only, we see how the other ingredients are affecting the starch properties. We see how the process is impacting the starch properties, which makes it really the best option for new product developments, to improve formulation, for R&D. Really, this is where you access a maximum of information. And to illustrate that, I just wanted to show you a couple of examples, quick ones, here about egg quantity on a cake batter. So we all know today that the egg price is already or is going to be a problem. And this is the same in the entire world. But the thing is that some manufacturers, they use a lot of egg in their formulation. And this is the case for a cake manufacturer. So we did a project here where we changed the quantity of, in the formulation, we changed the quantity of eggs. And we just looked at how the rheological behavior was modified. And what we can see is that if we remove eggs, if we put less eggs, then we will have a lowering impact. We will lower globally the consistency. But what is interesting is that we have our basis, the orange curve. The orange curve is our target, let's say. So you can see what is the effect of removing partly or completely eggs. And then you can test various other ingredients, maybe a potential replacer, in order to reach the orange curve again. And in the end, to ensure that you have no modification on your process or no modification on your final product. And here, this is just to show you what we obtained at the end of the test. So it actually looked like a cake crumb. Of course, with no alveoli, with no development, because there is no proofing step, but still it really looks like a cake crumb. And here another example that we worked on with an Italian manufacturer of crackers. Again, a lot of projects on cracker. And here the problematic is that they are working with a cracker with a very, very long resting time, 15 hours resting time. And they wanted to reduce it. But this is not like you can choose to reduce something like that and have no impact on the process. So they wanted to assess what would be the impact of this change. So what they did is that they analyzed the dough every hour or every 3 hours, and they checked what was the change. And as you can see, during the protein part of the curve, we have a big decrease. We can observe a big decrease of the torque, which is completely logical. The gluten is relaxing, but also there is protease in the formulation, which can explain that we have such a big drop. Sorry, inconsistency. But this is not just that. This information, we would have it with the instant consistency. But we would have missed this. There is a lot happening here with the starch during resting time. And this is not really a surprise either, because there is also amylase in the formulation and other ingredients that may react with starch. But what is clear is that the gelatinization intensity is really not the same. The starch resistance in mixing and heating is really not the same. And so probably it will impact many aspects of the final product. The color, the texture, the structure of the product will be definitely impacted. And so the idea here is that, again, you have your targets and you can see what makes that you reach your targets. What ingredients, what modification of the process, of the temperatures. Well, in their case, that was adding more enzymes. So, in conclusion, we really believe that the Mixolab 300 can be a game changer for the industry because it keeps all the benefits from the Mixolab that we already know and that we have proven to be very efficient, such as the fact that we can analyze 100% of the flour, not only the protein, but also the starch. And this can really help in improving specifications. We also have shown and proven that it's very well adapted to R&D purposes. You can analyze very different ingredients, very different enzymes, and see their effect on the flour. And it is also adapted to other type of raw materials, such as rice, corn, gluten-free, and also why not? Well, we have tested the cricket powder. We have tested many different things. The Mixolab is extremely versatile, and now we can enjoy this versatility even more because we can also analyze dough. We can also analyze dough quickly. Just have the consistency, which would be perfect for quality control, replace subjectivity with numbers. And by heating up and cooling down the dough, we can really have a very good fit for R&D to better understand how the different ingredients interact together. And really, in terms of versatility, this Mixolab 300 is opening a lot of doors. So who knows, maybe tomorrow we will work on, I don't know, a cheese or chocolate or any type of product. But yes, in the end, we don't believe so much in predicting from a flour what will happen. We do believe more in measuring what is happening. And measuring, it can start with the final product. You can measure objectively your final product, and this can be done very easily with vision inspection system, such as the one that are designed by iPro, which is another brand from KPM. And then we can understand how the recipe, how the process are impacting the final products. We can just have the information about the consistency of the dough, and then we can follow this consistency over the time. We can define what is the best flour according to the process, not according to the literature or according to, I don't know what specifications were designed at what time. But really just looking at the process and looking, okay, what is adapted and not adapted. Define what is the best flour and send this specification to the millers. Again, specification based on actual behavior on the line, which can be also very useful for millers as it will help them concentrate, focus on what really matters in terms of quality for their customers. All of that can be managed with the Mixolab 300. And as you can notice, at each of those steps, we will retrieve data. And data is the food for artificial intelligence. So by gathering objective data at each point of the process, you are also preparing for the next revolution, which will be AI. But in the end and in the meantime, we strongly believe mostly that what you can measure, you can control. If you don't see something, then you are completely blind and you cannot do anything about it. We should not be afraid of the information. More information means more possible action. So that's about that. Thank you very much for your attention. And then we will go to Q&R. Arnaud, let me join you.
Yeah, please. Yeah, the time you're joining me, I will maybe answer the first question. So the first question is, can you explain the curve for a standard bread and different parameters of data like the water absorption, stability, starch curve, etc.? Yes, we can explain that, but maybe not right now, not today, because that would take another hour or maybe more to explain you all the details. But very gladly, we can organize a Teams meeting with our local partner. So the best advice on that, if you can contact your local partners, and then we can organize a little team meetings when we are going to explain you all by details about the curve. We have a lot to say, so not that I don't want to answer, but that's an interesting one because we have a lot of information which I'm bringing.
What we can do in the meantime is maybe direct you towards the webinar that has been made available on YouTube. And that is also explaining, well, the basics of how to interpret a curve. So let us find the link and send it in the chat.
Good idea. The current question for you, Lena, how long does the instant consistency test takes?
This is a little bit the question. It's usually short, it's less than 8 minutes, but then the precise timing must be determined by testing the dough. We don't see the same discrimination at every point. Sometimes it can be as quick as 1 minute, and sometimes it will require a little bit longer, like 6 or 7 minutes. But in any case, that should be, yeah, shorter than 10 minutes.
That's why we have this learning mode, because depending on the type of dough, we can change the mixing speed, we can change the mixing time. So in fact, the learning is about finding the best condition when we have the best information. So most of the time we start by something long, and then we try to reduce without losing information. I'll take the other one. Next one. The next one is, can the Mixolab 2 be upgraded with the whole new dough system? No. No, we can't do that because it looks the same from the outside, but inside it's really different, and particularly the system for placing the tight mixer is really different. So we cannot make upgrade of existing system, but if you're interested in the Mixolab 300 that we have presented, and if you have a Mixolab 2, please get in touch with your local agent or distributor partner, and we are looking at some the best condition depending on the age of the machine, etc. But yeah, we will find a way of doing something. But yeah, we cannot upgrade yeah, in most conditions. So contact us.
Another question. Can you speak more to what advantage the Mixolab 300 offers for dough analysis over the Mixolab 2 plus a sampled dough kit? So the sampled dough kit is what Arnaud has presented at the beginning of the presentation. This was more a prototype than a definitive version. It was possible to analyze dough with that, and for simple, let's say, baking dough, that was, yeah, that was possible. But the real advantage of the new system is that it accommodates any type of dough, really, from batters to very hard dough. And above all, it makes it manageable by everyone. With the dough kit, the software was not adapted, which makes that the Mixolab was not understanding that you wanted to make a test, but without injecting water, you had to trick the Mixolab somehow, which makes it a little bit counterintuitive. You really have to want it to make a dough test with the Mixolab 2 and the dough kit, when this new version really makes it available and easy to make for everyone, even the least skilled operators.
Yep. Well, the one was Lena, so someone who knows you. In the measurement of starch and gelatinization, can Mixolab graph show it's the if the sample contain more amylose amylopectin? I will take this one.
All right.
Again, short answer is no. No, I mean amylose amylopectin will impact the curve. So if there is more amylose or more amylopectin, that will change the starch gelatinization and so on. But by looking at the curve, we do not know if it's starch properties because it can only also be amylase activity. If you have different wheat with different amylase activity, that will impact in the same area. But no, making the difference from amylose amylopectin is very tricky. So yeah, we know that high amylose will have a lower gelatinization on the Mixolab, but not to the point where we can really put a number on this one.
Yeah, I completely agree. The thing is that the Mixolab is a rheological equipment, so it doesn't it tells you how the dough is behaving. It doesn't explain why. And so you may have a shorter gelatinization, but maybe it's because you have more amylose. Maybe it's because you have more damaged starch. You don't know that. You have to conduct additional tests to understand what's going on.
Exactly. Thank you for the presentation. It is great to see more function. Okay. Two questions. First one, could we explain why the heating program used in the Mixolab choose to cool down to 50 degrees but not to 25? For a simple reason at the time. If you want to cool down to 25 degrees, that will make your test way, way, way longer. And I'm not sure it's going to, well, in standard dough, maybe in tricky doughs it can. I'm not sure it can, it will really give you more information. I don't remember if it's the lowest temperature we can.
The lowest is the lowest would be the temperature of the cooling system.
Okay. Okay, so we can go lower than 50 degrees. It's just the standard method is made like that. But yeah, again, it's a matter of information versus time you spent on doing the analysis, but we can always do.
If you're doing the very standard protocol for flour, the standard protocol is enough. But I know that some people, and particularly people working with ingredients that want more information about what's going on for shelf life, they tend to expand a little bit the last phase because they don't care so much about the time. So nothing prevents you to do something like that if you're interested.
Yeah, sure. The other one for you, is the new software able to export the data from the Speeder web data?
Yes, it is.
Yeah.
But the actual software should be able to do that as well. So if it's not the case, contact us.
Yeah. It's always possible.
Yeah.
The other one, we currently have the Mixolab before its new generation come. That's the cost of the machine. Is there a way to adapt the Mixolab 2 to have the same functionality as Mixolab 300? Well, that's the same question and that's the same answer. We cannot upgrade, but we can look case by case what is happening. So same thing, get in touch with your local distributors and we are going to look at the case. Will this work on stiff doughs?
Yeah, I think that we have shown some examples that we obtain on quite stiff dough, such as cracker dough. We also have worked with biscuit dough or even pasta dough. So far, so good, because again, the Mixolab is extremely versatile and so can adjust to many situations.
Okay. The only limitation we have is the sensor, which is going to about 7 Newton meter, which is quite stiff though. So if we are lower than 7 Newton meter, it's working fine. Well, it's 7, yeah, 5. But it's working. So yeah, usually it works. We can give it a try. We're not going to break anything. So can we clone instant protocol made from Mixolab 300 to be used in Mixolab 200?
So I'm not sure what is the point here because Mixolab 200 doesn't do dough analysis. And this is something that we have not really discussed during this presentation. Mixolab 200 is the version of Mixolab that is upgradable in Mixolab 300, thanks to a specific kit. But I don't, there is no dough mode.
Yeah, on the difference between Mixolab 300 and Mixolab 200 is that the 200 only measures flour, like the Mixolab 2 we have today. So that the same thing with some little improvement. But basically, on the Mixolab 200. You can do everything you were doing with the Mixolab 2, but no more. Mixolab 300 allows you to do everything you can do with the Mixolab 200 or 2, plus the fact of having the dough analysis. So if you are developing protocol for dough, you will not be able to use them on the 200 because you won't have the software part and you don't have the tight mixer. I hope we answered the question.
Unless you're great.
Lot of data. Will KPM ever be able to merge the final production data, vision, and the Mixolab data to enable a complete solution for the reverse engineering of final product to intermediate?
Yeah.
That would be a good idea. Huh?
That would be amazing.
That would be a good idea.
We are thinking about it.
Maybe.
Okay.
Yeah.
How can I tell if my Mixolab is giving false reading and needs calibration? Oh, that's a good question. I think you should contact service. We do have control flowers that you can test, flowers that we are following and analyzing here in order to determine what is the normal response of a Mixolab and what should be the tolerance around this response. So if you're out, then you know you have an issue, and then service can help.
Yeah. Another one? Yeah, just to precise about the thing for the upgrade of the Mixolab. The best is to contact your local distributors. So we cannot upgrade all the machines, but maybe in some cases we can look at that. What is sure is that we cannot do that on the field. The machine needs to go back to France. But yeah, that will be on a case by case basis that we are going to look at that.
Yeah, again, this is not an easy task. It looks very similar, but in the end, you have additional safety, you have additional magnets, you have a different shape of the cover, you have different shape of the back of the mixing bowl. So it's quite heavy.
It's not doable on site, that's for sure. I think we got to the end of the list. Okay, if you don't have more questions, we are going to thank you very much for your time. Also, if you have questions coming or popping, do not hesitate to contact us or to contact your local partners. The recording will be sent to you quite rapidly, I think. So you will receive a link where you can have the pleasure to listen to that again. And if you have more questions, of course, we are always there for you. Thank you.
Thank you very much. Bye.
See you.